I'll do the same on mine. So scale factor of 2, I'm going to say it's about right there. No. Yeah, sure. Give me it back. Okay. Regroup. Here we go. Here's will be A prime around there, and then B prime somewhere about right there. Look good? All right. If you haven't already, go ahead. Draw in line A prime, B prime. All right, geometry studs. What do you know about the two lines? I just dilated. That's what happens when I dilated the line by a scale factor of 2. It doesn't get any bigger or smaller. But what do I know about the two lines? Line AB and line A prime, B prime. What little symbol can I put in between them? Oh, boy. Parallel. What's the symbol for parallel? Hasn't been that long. Perpendicular. Yeah, just keep feeding your face. All right. All right. Yep. All right, everyone good there? They remain parallel. Okay, they remain parallel. Anytime you dilate a line, the lines will remain parallel, which means, let's go take that a little deeper now. They have the same slopes. Yes, they have the same slopes. Good. All right, remember that coming up in the future. Now what I want to do with you, same set of rules, but notice where point O was. This was off the line. What if point O is on the line now? What happens? All right, estimate where's A prime and B prime going to be again. Still a scale factor of 2 around center O, but now I just put O on the line I'm dilating instead of off of it. Watch what happens now. Where's A prime and B prime? Shouldn't be putting it in some white space over here. I hope not. Okay, we're getting further away from O in the same direction. All right, A prime about right here. What do you say? Right there. And B prime. Okay, watch. It'll go off, but it's still going to remain where? On this line I originally had, right? That's awful, but we get the idea. There we go. What happens then if the center's on the line? If my center's on the line, what happens to my new line? It remains the old one, doesn't it? Everyone see that? So if the center is on the line that you're dilating, AB and A prime, B prime remain the same line. So today it all comes down to, is the center on or off the line? Because if it's on, this is very easy. The new line is the same, the old line. All right? So either it moves or it stays right where it is. Okay? Either the line moves or the line stays the same. All right, let's hop into this. There's not too much to do here today. You're actually going to start reviewing at the end of class. All right, first question here. I got this line right here. 3x plus 4y equals 20. 3x plus 4y equals 20. I would like to dilate it by a scale factor of 1/3 around 0.42. I need your help. What's the equation of my new line? What do you say we get a look at how this bad boy looks on the graph? I'm not doing it with 3x plus 4y equals 20, though. How can I get a better look how this looks on the graph? What do I need to adjust here? Woo! 12. I want to graph this, but not looking like that. Put it into y equals mx plus b. Good. First step to do that. Let's roll. First step, 18. Minus the 3x. We're on our way now. Don't stop the train. 4y equals negative 3x plus 20. Not in y equals yet because of 24. Divide by 4. Okay. So y equals negative 3/4 x, and then what do you got over here? Plus 5. All right, I can graph that now. Maybe we'll see. What's my y-intercept? Because that'll be my first point I plot on the graph. What's my y-intercept up here now? Oh, 5. Oh, there you go. We got to have a name for that. 1, 2, 3, 4. We do. The answer is the number that comes up. Got to have a name for that. We'll figure it out later. Slope. 14. What's my slope up here?
Oh, negative 3/4.
Negative 3/4. So now I can go down 3, 1, 2, 3, to the right 4. 1, 2, 3, 4. If you want another point, do it again. Down 3, right 1, 2, 3, 4. So here's my line. All right, we're going to dilate it by 1/3 around 0.42. Anybody notice anything about 0.42? 0.42, where is it? 16? It's right here. It's already on the line. We graphed it. Oh, so if my center is already on the line, what am I going to know about my new line then? 24, what do I know about my new line? Remains the same. All right, so we're calling this, it looks like line P. So line P, no movement needed. What's the equation going to be for line P? 13. I can use the one I converted, or you want to use the original I gave you. Either one's fine because they're both the same. All right? So we're picking up on this now. If my center of dilation is on the line, whoa, we're not turning any pages yet. Get back there, please. What class are we in? Darn right we are. So let me talk about something else here before I go on to the next problem. How can you tell if the center is on the line without graphing? Because that took me, look, I had to convert it to y equals. I had to plot a couple points. Did it take me that long? No, but I could have found out quicker if 4,2 was actually on my original line or not. Got a suggestion, Will?
Just plug the coordinates into the original.
So here's my original equation. And I want to see if 4,2 is on there. Will, what's 4? That's what coordinate? So I say 3 times 4. And what's my y coordinate, Will? 2. Is that equal to 20? 12 and 8. Don't need your calculator. There it is. So that's algebraically how you could figure out. Because I don't care. I'll provide you with a graph. You guys have a ton of graph paper up here you could always use if you want to graph it. But if you don't want to graph it, you can do it algebraically to figure out if the point's on there or not. All right? Speaking of if it's not on there, how heck do I do it then? All right, look at, now you can turn. Yes, go ahead. Go ahead. Now we can turn and talk. All right, now I have 3/2 x minus 4. I want to dilate it by 3/4 at the origin. Okay, so I'll do both ways. I'll do it graphically and algebraically to see if the origin is on that line or not. So let's go graphically. What's my y-intercept up here? 15 y-intercept. 1, 2, 3, 4. So here's my first point. How about a little slope for me? 8 slope. 3 over 2. Up 3 over 2. Graph it in. Oh, nope, don't want that type of line. Let's take that type of line. All right, so there's my line. I think we can obviously say origin is not on it. If we did it algebraically, take a quick look. And again, you guys choose what's best for you. 0, 0. So 0 equal to 3/2 times 0 minus 4. Is 0 equal to -4? No, it's not. So it's not on the line. Okay, so that means I got to I can't just say it remains the same line. It's a new line now. All right, it just moved somewhere. When you dilate, what did we talk about at the very beginning? The lines remain parallel, which means they have the same 25 slope. What was the slope of my line originally? 4. So it's going to remain 3/2. y equals 3/2 x. Now let's talk. How do I find the new y-intercept? Remind me again, reread the problem. Where did I dilate around again? 20, where did I dilate around again?
The origin.
The origin. And don't I have a little shortcut? If I dilate around the origin and I know the scale factor, what can I do with the scale factor and a point to find the new point? What was our shortcut if I dilate around the center? 28?
Will you divide by?
Divide. Here you go. I should have gave you a little something else to work with there, Tyler. My fault. Here's your y-intercept right here, Tyler. Right? That point is 0, -4. And I want to dilate that point by 3/4 around the origin. Because it's around the origin, what can I do with my 3/4 in these points? What was our shortcut to get to the new point? Oh, stumped you for once, huh?
I don't remember.
Yeah, you do. Yeah, you do. What can if I have a point right now, I have 0, -4, and I want to dilate that by 3/4 around the origin. What could I have done with the scale factor and my points to get to the new ones? All right. I'm not going to let you off the hook. You're too good for that. Page 33. And you'll never forget again.
You multiply the coordinates by the scale factor.
Thank you. You multiply the coordinates by the scale factor. And the only coordinate I care about is the y-intercept. I don't care about this one. I want to see where the y-intercept moves. So, redemption. Redemption. You ready? 0, -4 times 3/4. What's my new point now? 3/4 times 0?
0.
Whoa! Uh-oh. -4 times 3/4.
-3.
Let's go, redemption time. -3. What's my y-intercept now?
0, -3.
3/2 x. Finish it.
Oh, well, -3.
Thank you. You good?
Yeah, I'm good.
Okay. Yeah, I'm sure. Everyone else all right? Slope stays the same because the lines remain parallel when you dilate. And to find my new y-intercept, I multiply by the scale factor. And I'll let you know, I know some of you may be thinking, well, what if you have us dilate around another point? I'm not going to do that to you. Okay? If the point's not already on the line, it's always going to be the origin. So you can just multiply by the scale factor. All right, I'm not going to do that to you. Any other questions, comments, concerns? All right. That took a lot out of me there, Tyler.
I apologize.
You should. Accepted. All right, now I didn't provide a graph here. All right, I'm trying to wean you off graphing every single time. It does take a while. So now I have y equals -3x plus 6. I want to dilate it by 2 again, but now around 0, 6. Not around the origin, around 0, 6. I think we can automatically get rid of these two, right? 3 and 4. Because I know I don't care where the center is, they got to remain parallel. So that's gone. Anybody tell me anything about 0, 6 and -3x plus 6? Is 0, 6 on that line? And let me know how you know. 26. Is 0, 6 on there?
Yes.
And how do you know?
Because you put the coordinates into the original.
I'm fine with that. 6 equals 3. -3 times 0 plus 6. 6 is equal to 6. Did anybody know a different way other than showing that way? Kyle, how else did you just look at the equation and say, whoa, 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 it's already on there?
Y-intercept.
Y-intercept is 6. 0, 6. They're the same thing. All right, so if the point's on there, what's the equation of my new line then? 5? Doesn't change. Same line. Okay, same line. All good? Before we do one more together here, we're going to have a little controversy with Aaliyah. Aaliyah's saying, well, hey, I got this line, 4x plus 3y equals 24. And we're going to dilate it by 2 around 3, 4. And she's like, oh, here's the new equation, negative 4/3 x plus 16. Is she correct? Well, why don't we do it ourselves, right? Why don't we do this ourselves and compare it at the end here? First thing, got to figure out if 3, 4 is on there or not. Is 3, 4? So that's the first thing I want you to figure out by yourself or in your group right now. Is 3, 4 on the line? Algebraically or graphically, I don't care. I'll do both up here while you're talking. Is 3, 4 on this line or not? On the line or not? 7 on the line or not? On the line. All right. So what should be the equation of my new line? 28. What should be the equation of my new line?
Y equals negative 4/3 x plus 8.
Okay. Should be this, what I've given you at the beginning. Tyler went ahead and already put it into slope-intercept form here, y equals mx plus b. So is Aaliyah correct or not? 13?
No.
Nope. Not honors material. No. The original line, the new line remains this. The new line is the same as the original. All right. And then I just threw in a rando dilation question down here. All right, we're not going to do this as a class because it can be done 2 different ways, and I don't want to take away a method from you if you want to do it another way. So you and your group, we're going to meet back here in 2 minutes, 2-3 minutes here. I don't want to say do it this way because there's 2 different methods to this, and I don't want to take it away if you want to do it a certain way. So go ahead, 2 minutes, talk to people in your group. A prime, B prime, 2.5.